Hello, welcome to Learn Page by Page. I'm Sally, and in this video I'm going to cover how to master Pythagoras Theorem. I'm going to go through 5 step-by-step examples, and this should give you all the skills you need for GCSEs, SATs or any other upcoming exams. Pythagoras Theorem formula is a squared plus b squared equals c squared, and I will explain this in more detail, but at this stage just need to know that it is used to find missing side measurements, not angles, and it only works with right angle triangles. And you can see this is a right angle triangle because you have that little square in the corner. If you have a triangle that hasn't got the square in the corner and is not telling you it's 90 degrees, it's not a right angle. Don't just assume if you see a triangle kind of like this that that's a right angle. It has to have that in the corner. Firstly, before we move on to any actual questions, let's look at this triangle and the formula. We know the formula is a squared plus b squared equals c squared. But what does that actually mean? Well, A, B and C are the letters that you will label your triangle sides with. C, this one here, that is always the longest side, and the longest side in any right angle triangle is this long length here, which we call the hypotenuse. The other two sides, A and B, can be this one or it could be this one. It doesn't matter, they're interchangeable. So you could call that A, you could call that A, and this could be B or that could be B. So it doesn't matter, just as long as you always label this long length C. Now let's move on to our first question. Here we're being asked to find C. The first thing we do with any Pythagoras Theorem question is we write down the formula. There's a chance, especially in GCSE, there could be a mark for even just writing the formula down. So we have a squared plus b squared equals c squared. Then you want to go ahead and label your triangle. Remember, C is always the longest side. It's always the hypotenuse. And you can see it's already marked C in this question. So we'll leave that. The other two sides, A and B, doesn't matter which one is A or B, and we go with that. And then what we're going to do is we're going to replace the letters with the numbers that we have. On this side, where A is, we have a 4. So instead of writing a squared, we're going to write 4 squared. And then wherever B was here. So instead of B, we're going to be writing 5. So we have 5 squared equals c squared, which we don't know. That's what we're trying to find. Then we're going to calculate 4 squared and 5 squared. And again, show you working out. So 4 squared is 4 times 4, and that's 16. And 5 squared, that's 5 times 5, and that gives 25, equals c squared. 16 plus 25 is 41. 41 equals c squared. The question is asking us to find c, and this is where a lot of students get stumped. You're not being asked to find c squared. This is not the correct answer. What we need to do is we need to get rid of this little 2. We need to get rid of the squared value, and the way we do that is we take the square root. So we're going to take the square root of this side, and whatever you do to one side of the equation, you've got to do the same to the other. So we're going to take the square root of this side, and that would give us c, because the square root of c squared equals c. Well, it's always a good idea to let the examiner know what you're doing. Take the square root of both sides, and the square root of 41 is 6.4 to 1 decimal place, and that equals c. You could write it round the other way, c equals 6.4, but it doesn't matter what way round you write it, it means exactly the same thing, but this is nicely presented for the examiner. Let's move on to another one. Here we're being asked to work out the value of x. So again, the very first thing we do is we write down Pythagoras Theorem. A squared plus b squared equals c squared. Then go ahead and label the triangle. We have A, B, and as before, the longest side, the hypotenuse, is always C. Now you notice here we actually have the hypotenuse measurement, and we have A, but we don't have B. So let's replace the letters with the numbers. That's 6 squared plus, now B is x, so that becomes x squared, and that equals C is 9. 9 squared. Again, calculate 6 squared and 9 squared. 6 squared is 36 plus x squared we don't know equals 9 squared, which is 81. And what we want here is we want x squared on its own. So we've got to move this 36. And remember, that is a positive 36. So to move this from this side of the equal sign, we've got to subtract 36. And we've got to subtract 36 from both sides. So let the examiner know what you're doing. Minus 36 from this side and minus 36 from that side. Subtracting 36 here, that's going to make that vanish and you'll end up with 0. So you're just left with x squared, which is what you want. Then the other side, 81 minus 36, that gives 45. And like before, we don't want x squared, we want x on its own. So we've got to get rid of this little 2. And so we take the square root of both sides. Tell the examiner that's what you're doing. Square root this side, square root this side, and that will get rid of the squared. So you're left with x, and x equals, into 1 decimal place, that gives us 6.7. And that's your answer. Now let's move on to the third one. This one, they're asking us to find the height of triangle. Sometimes they use these little symbols, ABC. Now, if you notice the ABC, they're capital letters, uppercase, and that is because they represent the corners, which mathematically are known as vertices. So uppercase letters, they will always be the vertices, the corners, whereas lowercase letters, A, B, and C, they will represent the sides. So let's go ahead and solve this question. Again, we always write down Pythagoras Theorem. That's a squared plus b squared equals c squared. Stage 2, label your triangle. A, B are the shorter sides and C is the longest side, the hypotenuse. Now let's talk about this being the longest side. If you look at a triangle, it's half a square or half a rectangle. And the hypotenuse being the longest side is the diagonal, which cuts the square into 2 equal halves. We call that bisecting. And so that's why this will always be the longest side. Let's get back to the question. We don't have A, so we'll leave that as a squared. B is 4.7, so that becomes 4.7 squared. And then C is 6.3 squared. Let's go ahead and calculate those. A squared stays the same, plus 4.7 squared is actually 22.09. 6.3 squared, 39.69. Same as before, we want a squared on its own, so we're going to subtract the 22.09 from both sides. So minus 22.09. Same on the other side, and that leaves a squared equals 39.69 minus 22.09 gives 17.6. And again, the square root of 17.6 and the square root of a squared is a equals 4.2 to 1 decimal place meters. And that's your final answer. This question, we've got ABCD is a trapezium. Find BC. Now, initially, you're going to look at this and you're not going to realise that you've got to use Pythagoras Theorem. But the question is asking us to find BC. And if you look here, there's a right-angled triangle. Well, this green line that I've just drawn here, that is the same as BC. So if we can just figure out this right-angled triangle, then we've got our answer. First thing we want to do is go ahead and look at any missing measurements. So take a ruler and let's draw that line in there. So we know that's BC, but what is here to here? Let's show that working out. That will give us 5. That's 5 centimeters there. So what do we have? Well, we have a right angled triangle, which we can label A, B, C as normal. Go ahead and write out Pythagoras Theorem. We have a squared plus b squared equals c squared. And our a was 5. So that's 5 squared. That's this one here. Our b, we don't know. So we keep that as b squared. And our c is 24. So that's 24 squared. 5 squared is 25 plus b squared equals, in 24 squared, 576. We're going to subtract 25 from both sides. Gives you b squared equals 551. Square root of both sides B equals, and that's coming up at 23.47, we'll make it 23.5 and it's centimetres. That's the length of B. That has to be BC, and so that'll be your final answer. And the last one is a little bit different because it's actually a graph question, but it's very common to get a graph question, especially on a GCSE paper, one of your last questions. You can have 2 points, like here, A and B, and you're being asked to calculate the distance between those two lines. Now they're telling you it's a centimetre grid. If it says it's not drawn to scale, you can't measure it. So you've got to go ahead and decide what mathematical method you're going to use to measure from that to that. And you can draw a right angled triangle and you can comfortably use Pythagoras Theorem. So let's go ahead and do that. First thing we're going to do, let's draw the triangle. Grab a ruler. I'm going to turn my ruler and make sure I keep this at 90 degrees. And then from there to there, let's go ahead and write down Pythagoras Theorem. A squared plus B squared equals C squared. Label our triangle. We'll call the bottom one A this time. We've used B every time before. We'll do B here. And our longest side, the hypotenuse, always C. Then we need to work out how long A and B is. So remember, we're going from here to here, and as you can see, that's going from 1 to 9. So A measures 8 and then B, so this measures 5. They're both centimetres. We've been told it was a centimetre grid. Then we can just go ahead and replace the letters with the numbers that we have. So A is 8 squared plus 5 squared equals C squared. 8 squared is 64, 5 squared is 25, C squared 89 equals C squared. Square root of both sides, square root of 89 is 9.4 equals C. Write it round the other way. Please your examiner. And that's your final answer. And that should be about everything. Hope it helps. See you next time.